In this video, I want to review solving equations with you. Let me remind you of what an equation is. An equation is a mathematical sentence that has a left side and a right side separated by an equal symbol. Now, this symbol is used so often in elementary school. We've used it so often to say, hey, I'm about to write my answer, that we forget what it really means. An equal symbol here between these two sides means that what's on the left has exactly the same value as what's on the right. So even though 3x plus 1 doesn't look like 13, it doesn't sound like 13, if there's an equal between the two sides, it means that they have exactly the same value. Just like 4 quarters doesn't sound like a dollar, doesn't look like a dollar, but they have exactly the same value. What does it mean to solve an equation? It means to find the value or the number that you can put in place of the variable or the letter that makes the statement true. So I'm not looking for a value that will make the statement false. I'm looking for a value that will make the statement true. What process are we going to use to solve? We're going to use the process of isolating the variable by using inverse operations. Now, isolate means that I'm going to try to get the variable by itself on the left side of the equation and everything else on the other side. Because if I can just get the x by itself, then my equation will say x equals, and I'll have a value on the right. Now, what are the inverse operations? Well, the beginning inverse operations that we're going to use are adding. The inverse of adding is to add the opposite. Multiplying. The inverse of multiplying is to divide, and the inverse of dividing is to multiply. Remember, an equation is like a pan balance. The equal sign is the balancing point. So, if the left side really is equal to the right side, notice that the pans are balanced. Now, as we solve, we are just going to continue to write different equations until we get the one that says x equals some value. Now, to do that, we are not actually going to change anything in either pan. We're just going to throw something else in. And when you throw something else in, it affects what's in the pan. We just have to make sure that what we do to the left side, we do to the right side, because the pans have to stay balanced. Let's solve this equation. Now, I realize that this equation and the next few equations are going to be so simple that you already know the solution, but let's practice on the easy ones so that we can learn the process. So, how do we solve an equation? We try to isolate the x. What does that mean? We try to get the x by itself on the left-hand side of the equation. Here, what's keeping the x from being alone? 5. How do you get rid of the 5? It depends. If 5 is added, I'll add the opposite. If 5 is multiplied, I'll divide. If 5 is divided, I will multiply. Now, this 5 is added to the x, so I'm going to add the opposite. What you do to one side, you see the pans just got unbalanced. I just threw something in the left pan, so I've got to throw the same thing into the right pan. Now, once you use an inverse operation, then you add these two lines together. So x plus nothing is x. 5 plus negative 5 is 0. That's why I threw a negative 5 into the pan, so that I would get a 0, because x plus 0 is just x, and now the x is isolated. It's by itself on the left. On the right, 7 plus negative 5 gives 2. Is 2 my solution? Well, to check to see if 2 is the solution, I need to check to see if I put 2 in place of x, does it make the equation true? Yes, it does. Well, then 2 is the solution. Now, please don't think 7's the solution. It's not. What's the solution? It's the number that I put in place of a variable that gave me this true statement. Let's solve this equation. What's keeping x from being alone? The negative 5. How do you get rid of a negative 5? It depends. If that negative 5 is added, I'll add a positive 5. But if that negative 5 is multiplied, I will divide by negative 5, because you see, you never ever multiply or divide by the opposite. You always multiply or divide by the exact same number. If that negative 5 is divided, I'll multiply by negative 5. Now here, the negative 5 is added to the x. Remember, we're thinking the plus sign. because if there's a plus or minus between two terms, we know it's an addition problem. So how do you get rid of a negative 5 that's added? You add the opposite. But the pan's just got unbalanced, so what you do to one side, you do to the other. How do you get rid of a 5 that's multiplied? You divide. Why does that work? Because the 5's cancel. 5 goes into 5 one time, 5 goes into 5 one time. 1 times x is x. 1 times anything is that value. So I've just isolated the x. So you do whatever operation you need to get rid of the number that's keeping x from being alone. How do you get rid of a divided by 5? Well, you multiply by 5. Why? Because then the 5's cancel and you get 1s, and 1 times x is x. But what you do to the left, you have to do to the right. How do you get rid of a fraction? Well, it depends. If that fraction's added, I'll add the opposite. If it's multiplied, I'll divide. If it's divided, I'll multiply. Notice here the 3/5 is multiplied. How do you get rid of a fraction that's multiplied? Well, normally you say, well, the inverse of multiplying is dividing, and it is. So I could divide both sides by 3/5. But remember that to divide by a fraction, you have to multiply by the reciprocal. So rather than having to go off to a scratch sheet of paper and saying, oh, 6 divided by 3/5 means 6 times 5/3, why not do it right here? Since everybody knows that to divide by 3/5 you multiply by 5/3, just go ahead and multiply by 5/3 here. Does that work? Yes, because the 3's cancel, the 5's cancel, I get 1 times x, which is x. But what you do to the left, you have to do to the right. Since 5/3 is a fraction, let's make 6 a fraction. We can cancel, multiply straight across. Now that we know how to isolate the x, now let's look at the entire solving process. Suppose we have a more complicated equation. Notice here I have the steps for solving more complicated equations. Notice that isolate the variable, which is what we've just been doing, is step 3. So when equations get more complicated, you always check to see if you can simplify each side of the equation first. You don't want to start working with an equation that looks like this. It's too difficult. So we're going to simplify each side first, make our work easier. Then we may need to collect the variables on the same side of the equation, and last of all we will isolate. So let's solve this equation. Notice there are parentheses on the left side of the equation. That means that this side is not simplified. I can use the distributive property to get rid of the parentheses. Now look at the right. On the right, notice that there are 2 x terms. Well, you can add x terms together. Notice I'm not using any inverse operation. I'm simplifying the left. I'm simplifying the right. You don't use inverse operations to simplify. Notice the right now is simplified. You can't add an x term to a -4. But on the left, I see that there are still 2 constants here. You can add 2 constants together, so let me add them. Now the left is simplified, the right is simplified. Now you might say, okay, now it's time to isolate the x. But wait a minute. There's an x term on the right side of the equation and one on the left. How do you know which one to isolate? Well, you don't. So what you do is you collect your variables on the same side. That is, I'm going to try to get these 2 variables on the same side of the equation. Now to do that, I do need an inverse operation. We normally like to collect our x's on the left. Therefore, I need to get rid of this 10x term on the right. Now, how do you do that? Well, the 10 is multiplied by the x. If I wanted to pull the 10 away from the x, since they're multiplied, I would divide. But I'm not trying to pull the 10 away from the x. I'm trying to pull the 10x away from the -4. They're added because there is a plus or minus between them. So how do you get rid of a 10x that's added to a -4? You add the opposite. But what you do to one side, you do to the other. Now let's add the 2 lines together. A 12x plus a -10x is a 2x. 26 plus nothing is 26. 10x plus -10x is 0x, and 0 times anything is 0. So this 0x just drops out. Hey, that's why I added -10x. So the x's would drop out on the right, and I would only have one x in the equation, one x term. Now I'm ready to isolate the x. How do you isolate the x? Well, you get it by itself on the left-hand side. Well, what's keeping the x from being alone? The 2 and the 26. Which one do you get rid of first, the one that's multiplied or the one that's added? Well, the order of operations says to multiply before you add, but when you're solving, you're going backwards. So you always get rid of what's added before you get rid of what's multiplied. Now, I think x is negative 15. I think negative 15 is the solution. Let's check and make sure. Now, before we do, there's a pattern I want you to see. Once we simplified both sides of the equation and we started solving, notice I've written the inverse operations in pink. Notice what we have. We have equation, inverse operation, new equation, inverse operation, new equation, inverse operation, new equation. So we just continue that process until we get the equation that only has the x by itself on the left-hand side. Okay, let's check to make sure negative 15 is the solution. I'm going to copy the equation just like it was, except everywhere there's an x, I'm going to put negative 15. Now, notice here I'm not going to use any inverse operations. I've got all the numbers. I'm not solving, so I don't need inverse operations. So I'm just going to use the order of operations. So I'm going to, on the left, I'm going to do what's in parentheses first. Inside the parentheses, I'm going to multiply before I add. Then I'll add. Now, outside the parentheses, I'm going to multiply by the 6 before I add the 2. So the left-hand side has a value of negative 154. What about the right-hand side? Now, over here, I can do these two multiplications in the same step because it's the same operation. Now, I can do those two additions in the same step because it's the same operation. So, when I put negative 15 into the equation, did it make the equation true? Yes. That means negative 15 is the solution. Let's look at one more equation. Simplify, collect, isolate. Simplify the left, simplify the right. Simplify the right again in this case. Collect your variables on the same side. Now isolate the x. Check your work. I love equations because you can always know when you hand your paper in whether you've made a 100 or not, because if your solution checks back, you know you have the right answer. So let's put in a negative 28. Notice I'm going to simplify the left side, get an answer. I'm going to simplify the right side. Notice I am not going to use the distributive property here. You never use the distributive property when you have all the numbers. It's harder. So notice here I just used the order of operations. I did what was in parentheses first. Now I'm going to multiply and last of all add.